Yes, I'm here with Litsa Kranias, and I'm gonna ask her to introduce herself because it's very impressive what I heard about you, and I'm very curious. Can you introduce yourself?
Sure. My name is Litsa Kranias. I am a professor at the University of Cincinnati, a distinguished research professor, and also a HANA professor of cardiology. And I have been there for at least 40 years, working on phospholamban all those years.
And it's great that you say so because when I was doing the preparation of this meeting, they all said you have to speak to Litsa because she is like the mother of phospholamban because you discovered it in 2010?
No, we discovered it much earlier. Actually, it was known that a small protein existed in the heart, but then we showed that it is phosphorylated in vivo in the intact heart. So it has a role in the human body during exercise and stress. It is the main regulator of contractility and the way the heart pumps blood to the periphery. And then we showed that if we take the protein out of the heart, or if we put more of it in the heart, it acts as an inhibitor of cardiac contractility. So your heart is always acting with a brake there, and when you need more blood to the periphery, phospholamban gives you that extra pumping activity because the catecholamines relieve the inhibition by phospholamban. And that was through the genetic models. When you take it away from the heart, you have a super heart, hyperdynamic function. If you put more of the gene in the heart, you have the opposite effect. You have depressed function, depressed blood to the periphery.
Okay. So you're like in charge of the research in the US. What's the current state of research right now in the US? What are you guys working on, and what are the great insights from that?
Yeah, actually, I am the coordinator in the US, and Peter Duvedance is in Europe, and we work hand in hand with the European laboratories and the US laboratories. And we have made tremendous achievements on the phospholamban mutant. We now know that the mechanisms of action are specific ones in the cellular compartment. So by understanding this, we can design better therapies for the patients, and those therapies are at different levels of testing. They are in cells, isolated cells, rodent models, and now we're moving to a pig model with these ideas. There are several ideas that we have about targeting therapy for this specific mutation. And finally, there is a therapy that Dr. Hajar and I have pioneered for heart failure. It is now in phase 2 trials, and we believe that this could be applied to the R14 deletion patients. So we're very helpful and very hopeful for that, I should say. Wow. And we're looking forward to the first experiments, first in mice models that have the mutation. Then we will see how we can prevent all the defects, and from then on we can move to the patients because the therapy is already approved for patients. Yeah. So very exciting times. Yeah. We're moving forwards at every single level, understanding how this mutation disturbs the cardiac function, trying to target these pathways, and also bypassing to prevent the disease.
I'm very curious because it's like you said, like you're really hopeful. Is that a last message that you want to give to the people who are watching at home? Like, we're hopeful about finding a solution?
Yes, I think we're very hopeful because we have a solution right now for heart failure patients. We can apply that to the phospholamban mutant patients in the near future, as soon as approvals are made. But then we have so many other options that we're pursuing right now that we believe a couple of different treatments could be available over the next few years. Yeah, we would love for things to move faster, but unfortunately, you have to go through many steps.
We have to be patient.
Yes. But we do work. All the scientists constantly think about the patients, and we work very hard around the clock for therapy for that disease.
Amazing. Well, it's great to be here and see all of the scientists work so hard. So I'm very curious what the next months and the next year will bring. Thank you so much for your time and your enthusiasm and everything. I was very grateful I could interview you, and I'm pretty sure the people at home will be too.
Thank you very much. Yes, we're all working for the patients, and we keep the patients in our thoughts and prayers on a daily basis as we look for new therapeutics for this disease.